In this video, I will show how to animate a drilling process. Create a new file. Go to Assembly4. Create a new assembly. In Parts, create a new body. Drill bit. In the Parts, create a new sketch. Select Model. Select LCS. Go back to Task. Select Paint Face. Click OK. Go to the sketch. Draw a circle. 10 mm diameter. Go to Parts Design. Pad it 180. Create a new sketch. Select XY plane. External geometry. And draw art. .3 mm diameter. Draw a line. Horizontal distance from this point 0.8. Select tangent. OK. Horizontal distance 4.1. Draw arc. Go to Parts Design. Select Subtractive Helix. .25 mm pitch. Height 100 mm. Select Z-axis. Select Subtractive Helix. Select Polar Array. Select 2. OK. Create a new sketch. XZ plane. Section view. Draw a triangle. Angle 31. Floor. Close. Roof. Okay. the geometry is complete. Go back to Assembly4, select parts, create a new body, call trunk, create a new sketch, select model, LCS, go back to task, paint face, OK. Go to the sketch, show 2 lines, $55, 25, polyline, $16, 10, 0.5, this 2, polyline, eight, 15, 9, 3, 1, go to Parks Design, select Revolution, OK. Create a new sketch, XC plane, draw a circle, 10 mm, pocket, full O, OK. Click the surface, create new sketch, external geometry, draw a line, (120 degrees), draw a construction line. (120°). Draw a line. (60°). Draw an arc. Another one. Close. Pocket it. 25 mm. Select the pocket. Select polar array. Make it 3. Okay. So it is the outline of a trunk. Change the color to blue. Go to Assembly4 first. Go to Parts, create a new body called Component. Okay. And then create a new sketch. Select Model, select LCS, go back to Task, Paint Face, OK. Go to the sketch, draw a square, (60 mm). 60 mm. Symmetric. Go to Parts Design. Pad it 10 mm. Click the surface. Create a new sketch. Draw a stadium. Diameter 20 mm. Length 30. Symmetric. Pad it 20 mm. Okay. Click the surface. Draw a new sketch. External geometry. Draw a circle. Select hole. Diameter 0.5. Depth 0.5. OK. Select the face, create a new sketch, external geometry. Draw a circle. Select hole, 0.5 diameter, depth 0.5. OK. Change the color to amber. Go to View. Change transparency to 70. Hide the component. Go to Assembly4. Select Assembly. Create a new sketch. Master. Select Model. Select LCS. Task. Paint Face. OK. Select Master. Draw a point. Distance 150. Draw another point on the vertical axis. $230. Draw a line. $180. Distance 10. In other line, $5. Distance from the point 10. Create new coordinate system for the master sketch. For the drill bit, select the long line, C tangent to edge. OK. Create another one in the component. Select the short line, C tangent to edge. I want to attach it to the bottom. With this in selecting mode, select the point at the other end. OK. Show the drill bit. Select the parts. Create new coordinate system. Drill C. OK. Select the circle. Concentric. OK. Hide the drill bit. Show the trunk. Select the trunk. Create new coordinate system. Trunk C. OK. Select the inside circle, concentric. Okay. It is where I put the jewel bit. Hide the trunk, show the component. Select the top. New coordinate system. So that is component, the first circle. Select the top circle with the first hole, concentric. Go to Z direction, make it -30. So it moves the LCS to the bottom. So now it's at the bottom. Also turn the Z-axis by 90 degrees. Okay. So hide the component. Go to Assembly. Import the parts. Jewel bit. Insert. Parent system. Select the M jewel. Okay. Import the trunk. Insert. Parent system. Same as the jewel. And then the component. Parent assembly. Component. Create a new variable. Time. Okay. Let's set up the conditional expressions for moving these parts. This is the conditions for moving the parts and jewel bit of this animation. Set up the variable as time, like in second. It also represents the unit distance. The component starts to move from time 0, stop at time 150. Jewels come down and turn for 40 seconds, and go up and then stop. Jewel bit moves to a new position in 30 seconds. Jewel the parts for 40 seconds, and going up and stop jeweling. At 340, the jewel bit moves back to the original position. At 370, the component moves till 520, and the process is complete. For the movement of the component, when time is greater than 150, it is at 150. Otherwise, it is same as a variable moving from 0 to 150. The conditional expression is variable stop time greater than 150 question mark 150 colon variable stop time. When the condition is true, the value after the question mark is the value for the variable. Otherwise, it's the value after the colon. When time is greater than 370, it keeps moving. The actual distance is from 150 to 300. That's why 220 is deducted. The second condition has only the first part of the conditional expression. If the variable is not greater than 370, it follows the previous conditional expressions. So we combine these two expressions into one, and it is a complete conditional expression. Put colon and open bracket to the first condition, and a close bracket to the end of the first condition. Add two conditions together, then we can copy and paste it in FreeCAD. The letter V in variables is capital letter in FreeCAD. These expressions applies to the horizontal distance of the component in the master sketch. Copy and paste the expressions to the master sketch. Open Expression Engine. Paste. OK, OK. Run the animation. From 0 to 520, step size 10. It looks good. The drill comes down for 40 seconds at time 150 and go back. The original position is 0. These are the conditions at different time frame. Only the first expression is a complete conditional expression, and all others have only the first part of the expression. Similar to the previous example, combine all 6 into one, like this. This applies to the vertical position of the drill bit in the master sketch. Copy and paste the expression for the drill bit. Go to master sketch, select the vertical distance, open expression engine, paste, OK, OK. Run the animation. The drill rotates at time 150 and 260 for 40 seconds. As the drill rotates only 40 degrees from 150 to 190, I multiply it by 27 so the drill rotates 3 turns. But it is in opposite direction, so make it negative when putting it in FreeCAD. It applies at the angle of the LCS of the drill bit at the master sketch. Copy and paste the expression for rotating the drill. Go to the LCS of the drill in the master sketch. Go to attachment. Go to angle. Make it negative. OK. 1. Move the drill to the second point at time 230 and move back at time 340. It is along the y-axis. Combine all 4 conditions. This applies to the y position of the drill bit LCS in the master sketch. Copy and paste the expression to move the drill from one hole to another hole. Go to M drill in the master sketch, open attachment, open position. Go to Y, paste, OK. 1. Drill holes at 190 and 300. The diameter changed to 10 at 190. Also the depth changed to 20 at time 190. When time is 300, diameter changed to 10 and depth changed to 20. This applies to the diameter and the length of the holes or the component. Copy and paste the expressions for the holes. Go to the first hole, diameter, OK, depth, OK. Take into account for depth. Go to the second hole, diameter, OK, depth, OK. Take into account for depth for the angle. Okay. Run the animation. Hide the LCS. If you find this video interesting, please subscribe and give it a like. Thank you for watching.